Let me introduce you to the most misunderstood character in gold prospecting, pyrite. Also known as fool's gold, also known as the mineral that has personally embarrassed more people than gravity ever could. Because pyrite doesn't just sit there quietly like a normal rock. No. Pyrite shows up shiny, confident, and loud, like it's begging you to overreact. It sparkles, it flashes, it looks expensive, it makes your brain go, "This is it." And then you realize you've just been emotionally manipulated by a mineral. That's why I call pyrite the drama queen of gold prospecting. But here's the twist. Pyrite isn't just a joke. Pyrite can actually be useful. Not as free money, but as a clue, a geological signal, a sign that a system was moving metals. So in this video, I'm going to do two things at the same time. First, I'll show you how pyrite tricks people and how to stop falling for it. Second, I'll explain how pyrite can still help you, because sometimes pyrite is basically the annoying friend who talks too much, but accidentally reveals the important information. All right, let's start with the basic truth. Pyrite is not gold. Gold is a native metal. Pyrite is an iron sulfide mineral. They can look similar in sunlight, but they behave differently, form differently, and matter differently. Gold is heavy and malleable. It bends, it flattens, it doesn't shatter easily. Pyrite is brittle. It breaks. It can form sharp crystals, little cubes, or grains that fracture when you stress them. Now, if you only remember one thing from this whole topic, remember this. Gold is stubborn. Pyrite is flashy. Gold tends to sit there like it's tired. Pyrite performs. And that difference shows up in the field if you know what you're looking at. Because pyrite has a habit of appearing in the same general environments as gold-bearing systems, especially hydrothermal systems with quartz veins, sulfides, and alteration zones. That's why it confuses people. It's not random that you see pyrite near quartz. It's not random that you see pyrite near rusty zones. So the real question isn't, is pyrite gold? The real question is, what does pyrite tell you about the system you're standing in? To answer that, you need a simple mental upgrade. Stop thinking one mineral equals success. Start thinking mineral association equals story. In many gold districts, gold doesn't travel alone. Gold is often associated with sulfides, pyrite, arsenopyrite, and others. Not always, but often. Those sulfides are part of the chemical environment that can carry metals and deposit them. So pyrite can be a sign that hot fluids moved through fractures. Those fluids carried sulfur and metals. The rock was altered. And a metal-bearing system existed here. That's already useful information. But it's not proof of gold. Pyrite is a clue, not a conclusion. Now, let's talk about the exact moment people get fooled. They see sparkles in quartz or in broken rock, and they start doing math in their head. They start thinking, if this much sparkles here, imagine what's deeper. This is where pyrite wins, because pyrite looks like it's offering you a shortcut, and prospecting is full of people who want shortcuts. So here's how to stop the drama. When you see something shiny, you do not ask, is this gold? You ask, how does it behave? Because behavior exposes identity. Gold behaves like a heavy metal. Pyrite behaves like a brittle crystal. In a pan, gold settles fast and stays low with heavies. Pyrite, if it shows up as grains, often behaves differently and doesn't have the same stay-put stubbornness that gold has. Pyrite can also oxidize and break down, meaning it doesn't always survive transport and weathering the same way. In your hand, gold doesn't look like sharp crystal cubes. Pyrite often does. And pyrite has another giveaway. It often has a more brassy, metallic shine, but not that deep, buttery gold look that real gold has, especially when you tilt it. But I'm going to be honest, lighting can fool you. Your eyes can lie. The field is not a controlled laboratory, so the smartest way to think is not, I must identify instantly. The smartest way is, if it might be pyrite, treat it as pyrite until you have enough evidence to say otherwise. Now here's where this gets interesting. Pyrite doesn't just fool you. Pyrite changes. It oxidizes. When pyrite oxidizes near the surface, it often creates rusty staining, iron oxides and hydroxides. It can create reddish-brown halos, crumbly textures, and sometimes cavities where sulfide crystals used to be. This is important, because this is why people keep saying things like, rusty ground can hide gold. Not because rust creates gold, but because rust can be the weathered fingerprint of a sulfide-bearing system, and sulfide-bearing systems are often where gold can exist. So when you see pyrite, or you see evidence that pyrite used to be there, you're looking at a system that had chemistry and fluid movement. That system might be gold capable, but again, might. So how do you turn might into a smarter target? You stack evidence. Pyrite alone is not enough. Pyrite plus structure is better. Pyrite plus structure plus alteration is much better. Pyrite plus structure plus alteration plus the right vein textures. That's when it becomes a serious conversation. So here's the field logic. If you find pyrite in random rock with no structure, no alteration halo, no repeated pattern, then it's just pyrite being dramatic. But if you find pyrite and the area shows a fault zone or shear zone, multiple veins, or a vein network, wall rock that looks chemically changed, bleached, softened, iron stained, broken and healed textures in quartz, consistent signs repeating along a trend. Now you're no longer reacting to sparkle, you're reading a system. That's the difference between guessing and prospecting. Now I want to talk about a very common trap that comes after people learn pyrite can be a clue. They swing too far the other direction. They start thinking, if pyrite exists, gold must exist. That's also wrong, because pyrite is common. Many hydrothermal systems carry sulfur and iron. Many systems produce pyrite with no significant gold at all. So pyrite is like a loud messenger. It tells you that something happened, but it doesn't tell you the final value of what happened. So the right attitude is calm curiosity. When you see pyrite, you don't celebrate, you investigate. And your investigation focuses on two practical questions. 1. Is this a strong repeated fluid pathway? 2. Does the alteration pattern suggest metal deposition conditions? Because gold deposition is not random, it depends on changes in temperature, pressure, chemistry, and the ability of fluids to drop metals. That often happens in specific zones: bends, intersections, dilation zones, repeated fracture networks. So if pyrite is present, you look for those focusing points. Now let's make this even more practical. There are 3 common ways you'll meet pyrite in the field. First, pyrite visible inside quartz veins or near vein margins. Second, pyrite in the host rock around veins inside altered zones. Third, pyrite ghosts, oxidation stains, boxwork cavities, rusty halos where pyrite used to be. Each one is a clue, but not equal. Pyrite inside a single clean quartz vein with no alteration, halo can still be low priority. Pyrite spread through an altered shear zone with a vein, network is much more interesting. Pyrite ghosts repeating along a fault trend can be very useful because they show the system was extensive and weathering is revealing its footprint. So the real skill is not spot pyrite. The real skill is interpret pyrite in context. And that's exactly what we're going to build next. In the next part, I'm going to show you how to separate pyrite that wastes your time from pyrite that points to a real mineralized zone using a simple evidence filter, structure, alteration, and oxidation patterns. And I'll explain the most common rust patterns that matter versus the ones that don't. If part 1 was about not getting emotionally fooled by pyrite, Then part 2 is about using pyrite properly, like a clue instead of a prize. Because pyrite can mean two very different things. Sometimes it's just common background mineralization with no real gold story. Other times, it's a sign you're standing inside a metal-bearing system that deserves attention. Your job is to tell which one it is. And the easiest way to do that is to stop asking, "Is there pyrite?" and start asking, "Where is the pyrite? How is it distributed, and what else is happening around it?" Pyrite becomes valuable when it's part of a pattern. So let's build a simple filter that works in the field. The pyrite filter. Location, pattern, and accompanying signs. First, location. Pyrite can appear inside quartz veins, along the margins of veins, in the wall rock around veins, scattered through altered zones, or as oxidized ghosts where the pyrite used to be. And those locations matter. Pyrite locked inside a single clean quartz vein might tell you only that fluids carried sulfur and iron. That's not automatically a gold system. But pyrite appearing repeatedly across a broader zone, especially in the wall rock and along structures, starts to suggest a larger hydrothermal system. Second, pattern. A single shiny spot is not a pattern. A pattern looks like repeated pyrite grains along a consistent trend. Multiple quartz veins carrying sulfides, an altered zone that continues beyond one outcrop, rusty staining that repeats along fractures or shear fabrics. If the evidence repeats, the system is more serious. If it's isolated and random, it's usually just pyrite doing pyrite things. Third, accompanying signs. This is where most people get it wrong, because they stop at sparkle. But pyrite only becomes a meaningful clue when it comes with at least one of these: strong structure, strong alteration, or consistent oxidation textures. So let's talk about those three supporting actors in a way you can apply quickly. 1. Structure. Pyrite loves the plumbing. Pyrite associated with faults and shear zones is more meaningful than pyrite in a random rock. Why? Because structure is what controls fluid flow. If you see pyrite and the area also shows a crushed zone, a shear fabric, rock looks smeared, stretched, foliated, multiple fractures and repeated vein orientations. A vein network rather than one isolated vein. Then pyrite is not just a mineral, it's a sign that fluids were moving through a long-lived pathway. That's one of the biggest prerequisites for gold-capable systems. A lot of people don't want to hear this, but it's true. Gold is more loyal to structure than it is to quartz. Quartz can fill any crack. Gold tends to appear where the system repeatedly focused fluids. So if pyrite is in a clear structural zone, your confidence rises. 2. Alteration. The chemistry around pyrite matters. Now look at the wall rock. If pyrite is present, but the surrounding rock looks completely fresh and unchanged, your confidence should stay moderate. It might be weak mineralization. But if pyrite is present and the wall rock shows strong alteration, now you have a better story. Look for bleaching. Host rock becomes lighter or washed out. Iron staining halos around veins or fractures. Clay alteration. Softer, crumbly zones. Silicification. Unusually hard, quartz-rich wall rock. Alteration is the system leaving fingerprints. It's what happens when fluids don't just pass through, they react with the rock. And gold-capable systems often leave strong alteration footprints, so pyrite plus alteration is more useful than pyrite alone. 3. Oxidation. Rust patterns. That matter versus rust that doesn't. This is where the rusty ground hunter gold idea gets abused. Rust is not gold. Rust is an effect. But rust patterns can help you read the footprint of sulfides, especially pyrite. So here are oxidation patterns that tend to be more meaningful. Rusty halos that wrap around veins or follow fractures consistently. Iron staining concentrated along vein margins and broken zones. boxwork textures, small cavities, or honeycomb-like patterns where sulfides oxidized away. Gossan-like material, rusty, crumbly, iron-rich caps above sulfide zones. These are signs that sulfides existed in volume, and weathering is exposing their imprint. Now here are rust situations that are often less meaningful. Random surface staining with no structural trend. Rusty soil that's uniform everywhere with no clear veins or alteration boundary. Staining that appears only in one tiny patch and doesn't repeat. The rule is simple. Good rust follows a story. Bad rust is just color. If the rust lines up with structure and alteration, it's a meaningful clue. If it's just random staining, it's not enough. The biggest mistake, treating pyrite as proof. Now let's be very clear. Pyrite is common. Lots of systems produce pyrite and no gold worth talking about. So your goal isn't to find pyrite and declare success. Your goal is to use pyrite as a metal system flag, and then check whether the rest of the system supports gold potential. So here's a clean way to rank what you see. Low usefulness pyrite. A small amount of pyrite in one isolated vein, no alteration, no structure, no repetition. Medium usefulness pyrite. Pyrite with some alteration or some structure, but the pattern is weak or limited. High usefulness pyrite. Pyrite and oxidation textures repeating along a clear structural zone with strong alteration halos and multiple veins or fractures showing repeated fluid activity. That ranking keeps you realistic. Now let's connect this to what you actually do next in the field. When pyrite is high usefulness, you don't just keep staring at it. You focus on where systems concentrate metals. Because even in a mineralized zone, the gold, if present, tends to concentrate in specific places. Structure intersections, bends and faults or shear zones, dilation zones, places that opened a bit more, brecciated sections that show repeated cracking and sealing, contacts where fluids reacted most strongly. So once you've identified this is a real system, the next step is not excitement. The next step is targeting. And that's exactly what part 3 is about, where gold tends to cluster in pyrite-bearing systems, and how to recognize the highest potential zones without wasting your time on the wrong parts of the same structure. Once you stop treating pyrite like a prize and start treating it like a system clue, the next question becomes simple. If this is a real mineralized zone, where does gold actually concentrate inside it? Because even in a good hydrothermal system, gold is rarely spread evenly. Most of the rock can be dead. Most of the quartz can be empty. Most of the pyrite can be just background sulfide. Gold, when it shows up, tends to show up in hotspots, and those hotspots follow a logic. The easiest way to understand it is this. Gold likes places where fluids were focused, pressure changed, and chemistry shifted fast enough for metals to drop out. So you're not only looking for pyrite exists, you're looking for where did the system do the most work? Let's break down the hotspot logic into a few clear patterns you can actually apply. Hotspot pattern, yes, intersections and cross-cutting structures. One of the most common concentration zones is where structures meet. When two fracture sets intersect, you get more pathways, more open space, more turbulence in fluid flow, more chances for minerals to deposit. So if you find a pyrite-bearing zone and you see a second set of fractures cutting across it, or you see a quartz vein set intersecting another set, that intersection is usually higher priority than a long, straight, uniform section of the same vein. Straight sections can be transport routes. Intersections can be drop zones. If the system is a highway, intersections are where traffic piles up. Hotspot pattern, bends, jog zones, and kinks in the structure. Faults and shear zones aren't always straight lines. They bend, they step, they jog. And those changes in geometry matter because they change stress and permeability. A bend can create dilation, small openings that let more fluid move through and deposit minerals. A bend can also create repeated fracturing. Rock breaks more in those zones. So if you can trace a structure and you notice a kink or a bend, pay attention. The system often concentrates in those sections because the structure is mechanically active. In simple terms, uniform structure = stable pathway. Bends and jogs = disturbed pathway. More openings, better trapping. Hotspot pattern = brecciation and repeated healing. Now let's connect to texture. Brecciated zones, where rock is broken into fragments and then cemented back together, are often high priority. Because brecciation means energy, it means movement, it means repeated opening and sealing. And repeated opening and sealing is exactly how a system builds concentration. In pyrite-bearing systems, brecciation often comes with quartz cement, sulfide cement, oxidized cavities after sulfides weather away, strong iron staining along fracture networks. So instead of focusing on the cleanest quartz, you focus on the most worked quartz, the sections that look broken, healed, and disturbed. Those are the sections that often host the most deposition events. Hotspot pattern. The contact zone. Edges beat centers. This is one of the biggest mistakes people make. They break the whitest part of quartz and ignore the margins. But gold-associated minerals often concentrate at the quartz wall rock contact. Fractures along the margins, altered wall rock next to veins. Why? Because that's where fluids meet new chemistry. When fluid chemistry changes quickly, because it hits a different rock type or reacts with altered minerals, metals can precipitate. So if you have pyrite in a system, don't just look inside the vein. Look at the boundary zones. The ugly edges often matter more than the clean center. Hotspot pattern. Alteration intensity zones. Gold-capable systems often create strong alteration patterns, but the strongest alteration isn't always spread evenly either. Sometimes you'll see a narrow band of intense iron staining, a zone of bleaching and clay alteration, a hard silicified core with altered margins. When you see a change in alteration intensity, like a strong halo that suddenly intensifies, those transitions can indicate focused fluid flow and stronger reactions. So you're not only asking, is there alteration? You're asking, where is the alteration strongest and most consistent with structure? Where pyrite fits into all this pyrite is useful because it often follows those same hotspots. In many systems, pyrite can be more abundant near intersections, more concentrated in brecciated zones, stronger along vein margins and fractures, heavier in altered wall rock near active pathways. So the presence of pyrite is not the end of the story. It's a marker you can use to track the system's most active zones, if you read it correctly. Now here's the important reality check. Gold can be microscopic. Even if you're standing in the right system, you may never see visible gold on the surface. Gold can be locked inside sulfides. It can occur in tiny grains. It can be invisible without processing. So the goal in the field is not, I must see gold. The goal is, identify the hotspot geometry where gold is most likely to deposit if the system is gold-bearing. That's the honest approach. Quick hotspot checklist. You can remember. If you're in a pyrite-bearing zone, prioritize intersections of structures, bends, jogs, and stepovers, brecciated and healed textures, vein margins and contact zones, areas with the strongest alteration and consistent oxidation patterns. That's where systems focus energy, fluids, and reactions. Now, once you understand hotspots, the final step is decision-making. How to rank targets fast, when to stay, when to move, and how to avoid spending your whole day on pyrite that looks impressive but doesn't stack enough evidence. That's part 4, the last part of this series. Now that you understand how pyrite can be useful and where hotspots form, the last step is simple. How do you make decisions fast in the field without getting stuck, without getting emotionally attached, and without wasting time on dramatic pyrite that doesn't have the full package? Because the biggest danger isn't that pyrite fools you once. The biggest danger is that pyrite makes you stay too long. So this final part is a clean decision system you can use every time you see pyrite, sulfides, rusty ground, or quartz veining. It's built on one idea. You don't need certainty. You need a ranking that guides your time. Step 1. Score the site. Using the 3 pillars, when you arrive at a pyrite-bearing spot, you check 3 pillars: structure, alteration, mineral evidence, and you're not looking for perfection. You're looking for strength and consistency. Structure means faults, shear zones, fracture networks, repeated vein orientations, intersections, bends, brecciation, anything that suggests repeated fluid pathways. Alteration means chemical change in the wall rock, rust halos, bleaching, clay zones, silicification, especially when it follows a trend and repeats. Mineral evidence means sulfides present or sulfide ghosts, like boxwork cavities, consistent iron oxide staining, gaussian-like textures, and metallic grains tied to the system. Here's the rule that keeps you honest. If you only have 1 pillar, you treat it as low confidence. If you have 2 pillars, it's worth targeted testing. If you have all 3 pillars repeating along the same zone, it becomes a serious target. That's it. That's the foundation. Step 2. Use the hotspot filter before you invest time. Even in a good system, not every meter matters, so before you commit time, you apply the hotspot filter. Are there intersections? Are there bends or jogs in the structure? Is there brecciated and healed texture? Are the margins and contacts strongly altered? Is the alteration intensity stronger in one specific section? If the answer is yes, you focus there. If the zone is uniform and featureless, you don't camp there just because pyrite looks shiny. Uniform zones often represent transport pathways. Hotspots represent deposition points. Step 3. Make the decision. Stay, move, or mark. This is the practical part. You decide one of 3 actions. Stay. You stay when you see a coherent story, a clear structural zone with repeated features, alteration that follows the structure and repeats, sulfides or oxidation textures that match the story, and at least 1 hotspot feature: intersection, bend, brecciation, or strong margin mineralization. This is where your time has the highest chance of producing meaningful results, whether that's better samples, better concentrates, or just stronger confirmation. Move. You move when pyrite is present, but the system is weak. Pyrite in random rock with no structure. Rust that's everywhere and doesn't form a pattern. 1 isolated quartz vein with no alteration halo. No repetition, no trend, no hotspot geometry. This is the dramatic pyrite category. It shines, it tempts you, but it doesn't stack evidence. If you stay here too long, you're donating your time to the earth for free. Mark. You mark the spot when the evidence is good, but conditions limit you. You can't safely access the best exposure. Overburden is too thick. Water level or terrain blocks the zone. You can't follow the trend today. Mark it, map it, and come back when conditions allow. This is how you build real progress over multiple trips instead of starting from 0 every time. Step 4. The common mistakes to avoid, quick and direct. Here are the mistakes that pyrite causes most often. Mistake 1. Treating sparkle as proof. Mistake 2. Sampling only the cleanest quartz instead of the margins and altered zones. Mistake 3. Testing one point and declaring victory or failure. Mistake 4. Ignoring structure and chasing whatever looks bright in sunlight. Mistake 5. Staying too long without stacking evidence. If you avoid those, you instantly get more consistent. Clean closing. So here's the honest summary. Pyrite is not gold, but pyrite is not useless either. Pyrite is a loud signal that a system moved sulfur and metals. Sometimes that system includes gold, sometimes it doesn't. The difference is not determined by excitement, it's determined by context. When pyrite is tied to strong structure, strong alteration, and consistent mineral footprints, you may be standing in a real mineralized zone. Then, your job is to target the hotspots, intersections, bends, brecciation, margins, where systems tend to concentrate metals. If the evidence doesn't stack, you don't argue with it. You move. That's how you stop pyrite from wasting your time. And that's why I call it the drama queen of gold prospecting. It's loud, it's shiny, it gets attention. But only the people who stay logical get something useful out of it.